In today's world, data is the new gold. Data scientists unlock insights from raw information. They use statistical methods to analyze trends. Data analysts convert data into visual stories. By creating dashboards, they help organizations make informed decisions. Machine learning models can predict future outcomes. They identify patterns that aren't visible to the naked eye. Data cleaning ensures accuracy and analysis. Collaboration across departments enhances data insights. They utilize programming languages like Python and R for analysis. Cloud computing resources expand their capabilities. With big data, they tackle complex challenges across industries. Ethics in data science ensures responsible use of information. The future of data science looks bright with endless possibilities.
Hello, you are welcome to class. My name is Jude Chukwudi Ilobelu, your anchor for the program. This is our day 10 class for Python machine learning class. We have taken our time to touch into various aspects of Python, and today we are going to start to understand machine learning. So the course outline for our class, we start with introduction. We look at what machine learning really means, how to apply machine learning, the type of learning algorithm that is open to us, and machine learning process. So we also look at data processing. We want to know what it is. We look at exploratory data analysis. We look at other things. Supervised learning, natural language, we are touching briefly on that. We look at performance metrics for classification, which will include accuracy, precision, recall, F-score, amongst many. Then the implementation in Python. We want to know how to use k-means clustering, hierarchical clustering, linear regression, logistic regression, amongst many. So you sit back and we'll see how far we can go. Then we'll continue until we finish the class. Then we'll enter into our project proper. Introduction to machine learning. So what actually is machine learning? So say machine learning is a method of data analysis that automates analytical model building. This is done using algorithms that iteratively learn from data. Machine learning allows computer to find hidden insight without being explicitly programmed to look for where to look for it. So what are we really saying? We are saying that machine learning is a different ball game altogether. It is a system of analysis that a kind of allow the system, the computer or the machine to learn through experience. You don't have to use different kind of code in order to bring a kind of action. There is a learning process by the system. After it has done one or two things, it can be able to make some level of accurate predictions which can be relied upon for decision making. So we can also define machine learning as the field of study that gives computer the ability to learn without being explicitly programmed. So we are talking about a system when the machine works, but it is not programmed to work. It works based on experience. So a computer program is said to learn from experience, which is E, concerning some task T and some performance measure P. If the performance on T as measured by P improve with experience. So we're talking about learning, gaining experience, and improving performance. That is all we are saying here. So if the computer learns previously or the first attempt, it made maybe 40% progress, and when you repeat the same procedure, the same process over time, in subsequent adventure, the computer improved to 60, 70, 80, up to 90. We can say that the computer is learning from experience, so it improves performance. That is what machine learning is all about. But you have not programmed this computer to do what it's doing, but it's learning based on what assignment that have been given to it. For if you take for example traffic pattern at a busy intersection, task T, you can run through a machine learning algorithm with data about past traffic pattern, which is the experience, and if has successful learned, it will then do a better at predicting future traffic pattern performance. So for instance, some of these our street light to see, what happens is that the system learns the flow of traffic. After a particular period of time, it becomes conversant. It can able to predict the quantity or the volume of traffic, and also apply the uh, the the usual flow after it has learned. We can also see that in if you drive boat or Uber or Rider, for instance, you see that the map over some time have been able to dictate places of high traffic flow. When you look at the map, it will show you in red if they are very heavy at particular period of time, and sometimes it will show you in yellow. It means that it has learned over some time, so it can able to predict. And if you get to those places, you will of course see that there is some level of traffic congestion with some level of accuracy. It is what machine learning is all about. So application of machine learning, where do we apply this important topic? We can see it in various sectors and departments. It can be found in manufacturing sector, retailing sector, healthcare and life sciences, travel and hospitality, financial services, energy feedback, and utilities. For instance, when you look at manufacturing sector, machine learning can be very, very important. One, in predictive maintenance or condition monitoring. Predictive maintenance, you can be able to predict when maintenance of a particular machine is due, especially if you are working in big factory. So you don't need to wait until it breaks down. Machine learning can be able to be used to determine that. It can also warrant reserve estimation, propensity to buy, when to buy raw material, especially if it has to do with stockpiling, and also prices, changes in prices. It can tell you the time it's good for you to buy and when it's good for you to stockpile. Then it's also good for processing or process optimization. We're talking about process, production, delivery, inventory, and out. So it is very, very important. For retailing, it is good for predictive inventory planning. You plan the inventory so that you don't run out of stock. It also have recommendation engine, which is one of the projects we are going to look into. You have issue of upsells and cross channel marketing. So you know when you can be able to use marketing to sell a product and also sell the ones that are also related on a vertical relationship, or the one that are related on a horizontal relationship. You can be able to use machine learning to determine that. Market segmentation and targeting, can able to use machine learning to divide the market based on some level of criteria or perception. So you can able to segment market based on demography. You can separate market based on location. You can separate market based on other criteria. Customer return on investment and lifeline value can also be seen from there. When you look at travels and hospitality, for instance, you can see that aircraft scheduling is also what machine learning can do. Dynamic pricing, when you come to issue of air ticketing, for instance, you discover that in a particular plane that is moving to a distinct location at a given time, you'll be surprised to see that different customers has different pricing. So it is the utilization of machine learning that helps to set these prices so that the business can be floating and making returns. Social media, consumer feedback, and interaction analysis are also part of it. Customer complaint resolution, you can able to, because of the ability to predict, can know where there is shortfall or weakness or weak line or weak link, be able to get things done. Traffic pattern and congestion management, just as we see also in maybe as we have discussed earlier, traffic pattern is part of what you can see there. So this is part of what machine learning can be able to be used to achieve as a tool of a data science application. So we can also talk about some common machine learning use cases like recommendations. Companies like Amazon, Netflix, they use intelligent machine learning algorithm to analyze activities and compare it to millions of other users to determine what a customer, a client may like to buy or being watched next. So for instance, when you click on your laptop, if you are in the internet, you will see some items, some merchandise may prop up, and on most cases, what are propping up is what possibly you may have desired, because one time or the other you may have clicked on those sites, and because you have clicked on those sites, the machine cannot be able to view and understand that this is where you will possibly like, so they will quickly come and give things that may interest you. So it's kind of a recommendation. Machine learning is also good for fraud detection. PayPal, for instance, is using machine learning to fight money laundering. So this the company a kind of use a kind of a complex kind of a system algorithm to detect when payments are made fraudulently and when it is made without fraud. So the company has tools that compare millions of transactions, so it can precisely distinguish between legitimate and fraudulent transactions between buyers and sellers. They also have online search like Google engine, for instance, and its competitors are constantly improving what search engine understands. So every time you execute a search on Google, the program watches how you respond to the results. If the search engine didn't search up the result you wanted, the program learn from the mistake to deliver a better result. So that when you come next time is always important. Sometimes when you go to your mail, the things that interest you is what come, especially on your spam. They come on their own because they have seen the kind of things that you like visiting. So they will quickly want to take the opportunity for business improvement. So we have different types of machine learning method. We have different types, but basically we have three. One is supervised learning, the other one is unsupervised learning, and the third one is reinforcement learning. So for supervised learning, what is it all about? So it deals with learning a function from available training data. The algorithm are trained using label examples. So what is this saying? We are saying that supervised learning is a kind of learning that has a particular label or output that has a name that one can actually pinpoint and say this is the output. For instance, let me use economic term. Y is a function of x. That means we are seeing that whatever is responsible for y is being triggered by x. So y is the label because we are seeing y as the output, even though that output is affected by x. Now, for supervised learning algorithm analysis, the training data and are inferred there, and the product they produce are inferred function which can be used for mapping new example. They are commonly used in application where historical data predict likely future event. So in label, we are seeing the outcome, we know the outcome. It has already given us the outcome. The outcome is price. The outcome is profit. The outcome is satisfaction. That outcome is label. We know it as Y. So common example are classifying email as spam. So when we classify an email, this is a spam. What we are trying to do is to determine whether an email is either a spam or not a spam. So at least we know that spam is what we are looking at. So that makes it to be our Y, which is a known factor. That it can be called a label. We have given it a title. It has a name. So anticipating when credit card transactions are likely to be fraudulent, or which insurance customers are likely to file for it, to file okay, this is not complete, to file a complaint or not, is what we're talking about here. So these are examples of supervised learning. We can also look at unsupervised learning. These are the kind of the learning process our machine that we want to subject to learning and experience and improvement or making success can go through. When a machine learns through a supervised learning environment, the outcome is quite different from when it learns from another source. Now, for unsupervised learning, it makes sense of unlabeled data without having any predefined data set for its training. Normally, in a machine system, we have, first of all, we have data set. Data set can be outcomes of what has been happening over the years. For instance, Nigeria GDP, economic outcome or performance. We can say GDP, which is a function of different aspects of macroeconomic activity, which will include, for instance, the price, the output, amongst other things. And if we're able to chart it over the years, we can able to predict GDP through extrapolation. That is, we are using GDP as a factor which can give us a leading. So we're talking about supervised learning. Now, for unsupervised learning, we don't actually have a label. That is where the issue is. But we want the system, the algorithm to learn. But there's no particular label to say this is GDP, this is spam. No. You have a congregation of data, and this data, which will break into training set and into test set, sometimes into validation set, those data do not have a label. So that is where we have issue. But that is what supervised learning is all about. Unsupervised learning makes sense of unlabeled data without having any predefined data set for its training. It is most commonly used for clustering similar input into logical group. So now we have to now fashion out an algorithm or a system or a pattern in which we can be able to bring this data and find a common point or similarity and break them into clusters based on some given conditions or preferences or given definition. Though, like when we want to do our hypothesis, we set a precondition. Say this hypothesis, I'm giving myself not to be 5% what outside of 5% error, and I begin to work. It's not when I go halfway I will not begin to change. That is exactly what happens here. So the goal is to explore the data and find some structure within, because basically every data has a structure. So we'll find that structure. We'll look at the difference between and difference within a given group or a given attribute, and we'll begin to use it to work. We shall see that in practice. So common example of unsupervised learning are: one, identifying segments of customer with similar attributes. Customers that like to drink Coke, for instance, may be different from the one that like to drink malt. and may be different from the one that like to drink beer or the one that only like to drink water. Based on that, we can begin to divide, we can begin to cluster, and get a kind of attribute that can help us to do this algorithm. That is what it's telling us here. So, segmenting text topic, for instance, is another a good example. Recommending item and identifying data outline is also another example. Here we have semi-supervised learning, but most literature may not carry it, but it's something that is worth looking at. Say semi-supervised learning. Now this is not completely supervised, and it's completely not unsupervised. That's what it's saying. Uses both label and unlabeled data for training. Typically a small amount of labeled data with a large amount of unlabeled data. The reason is that when you get data that are mostly labeled, they are very, very expensive to generate or to get. So it makes sense to use less of expensive data if cost minimization is what part of your target. So unlabeled data is less expensive and takes less effort to acquire, but of course you have a lot of work to do. So this type of learning can be used with methods such as classification, regression, and prediction. We are going to look at all this and understand what they are. So semi-supervised learning is useful when the cost associated with labeling is too high, as I said earlier, to allow for fully labeled training process. So identifying a person face on a webcam can be a good example. Now, reinforcement learning is another important type that we are going to also look. So what are reinforcement learning? So reinforcement learning is a kind of a more technically advanced form of learning. So with reinforcement learning, the algorithm discover through trial and error which outcome yield the greatest reward. So this one has what we call reward and penalty. When a robot is constructed, for instance, when a machine is constructed, for instance, now it is made to go into physical or proper trial, maybe life trial. Now if it's able to achieve the desired good, for instance, moving to set target or desired area and bringing the result and coming out, now the system rewards it, and when it fails to achieve it, the system penalizes it. So over a given period and over subsequent trial, the system must have learned because of what he has seen through reward and penalty and continue to improve. So that is why we are talking about reinforcement. It learns from past experience and enforces it in subsequent trial and becomes better. So this type of learning has three primary components. One, the agent. The agent is the learner or the person that makes the decision. Two, the environment. Everything the agent interacts with is the environment and the action, what the agent can do. And the objective is for the agent to choose action that will maximize the expected reward over a given amount of time. It's often used for robotic, gaming, and navigation. So looking at supervised and unsupervised machine learning method. So when we look at the machine learning, that is the main thing. Now we also have other kind of learning. We have deep learning, we have natural language, we have Python is bigger body, machine learning is a smaller aspect. Now it is now broken into supervised learning and unsupervised learning. So for supervised learning, you develop predictive model based on both the input and output data, what comes in and what goes out. Now for unsupervised learning, we group and interpret data based only on the input data. While supervised will look at input and output, as I talked about the y and the x, in which the x affects the y and the y is the output we are looking at. But for the unsupervised, we are only looking at what we put inside. What goes inside is what is our primary concern. Now for supervised learning, we can have classification problem and regression problem to solve. Under classification problem, we are taking whether we are classifying it into yes or no, 1 or 0, true or false. When you say the man is a thief, for as an example, all we want to do is to classify the man either as a thief or not a thief. So it's either 1 or 0, it's either true or false, it's either yes or no. Now, but for regression, we are looking at what is affecting what. So that is why regression is different from classification. What is affecting what? By what degree? Now, for unsupervised, mostly we are looking at clustering analysis. How can we be able to segment our input in such a way as to draw inference and logical ideology that will help us to make important decisions. So for machine learning process, we'll go through different modeling or different segmentations. The first thing here is feature extraction and scaling. When you remove the important features, normally these features we're talking about is just like the columns. All the items on top of the columns are your features. So that is what describe a particular identity or ID. For instance, the first ID on the row 001, you have maybe the gender which is on the column. You can write a male, maybe you can write age, you can write adult, maybe you can talk about height. You can be able to put up the height. You can talk about whether he's married or not, whether all those attributes on the top, on the column, these are all features. So we are looking at feature extraction and scaling. They also look at feature selection. It's not everything that is on top of that column that is useful to us. Some of them will be trimmed out because they may not be needed when we start our analysis. We also talk about dimensionality reduction. For dimensionality reduction, we are looking at not using every aspect. We are going to ensure that our data, our feature, are as small as possible in order to carry the message and to deliver the result. Then we're talking about sampling, a particular given set of sample and how it works. So from there, we can see label and raw data. This is what comes in as input. So when it comes as input under pre-processing, we now divide this data set that we have into 2 and sometimes into 3. But from this diagram, we're divided into 2. We have training data set and we have test data set. Remember, we said that the system learns. So if the system is learning, there's a need for us to hide some data so that the system does not see it and learn from the training data. We'll come later to see if you can be able to exact what it has learned on the test data which it did not see all along. So this training data set, we now move it to the learning process. The under learning algorithm, you see that model selection is done there. We can also do cross validation, which we'll also explain later, performance metrics, hyperparameter optimization or hyperparameter tuning. This is what we do under the learning environment. Then after that, we'll go to the next stage, which is final model. You can see that our test data is brought to our final model, which will now give us a label. And from there, we'll move to new data set and label and the labels, which we can now use this data here that we have got to here to make our prediction. So this is just a machine learning process, how the machine learns. So the machine learns, and from the learning, it can be able to give us what we can use as prediction material in order for us to redeploy it into the system and begin to use it to make important output. Now, pre-processing of data. We say that pre-processing is all what we do before we go into the actual processing of our data. It is just like a prep. We look at our data again. We look at some criteria and begin to take care of it before we go into processing proper. So we have different types of data. So we start from the variable and we break those variable. Variable can be any given data set, or any given factor can be a variable, and it can either be a categorical variable or it can be a numerical variable. For categorical variable, it's just like qualitative in nature. Like I said, when you have a male and a female and you want to begin to categorize them, you can, because you are using a matching system, you can give it, assign 1 to a male and 0 to female, or you can assign 1 to a female and 0 to male. It does not mean that the one that has 1 is superior to the one that has 0. You are just assigning these values for the sake of data analysis. So at that particular point, we are saying that they are qualitative and they are categorical, because they are not actually a given magnitude in terms of what they can do in calculative balance. Now, for the, if it is, the variable is not categorical, it may be numerical, and when it's numerical, it means it has number just like an integer. So those numbers have weight and they are quantitative in nature. And you see, this categorical um, data have characteristics. So also is the numerical data, they also have characteristics. So for categorical qualitative data, they are nominal in nature or they can be ordinal in nature. So when they are nominal, you say the category are mutually exclusive and unordered. Just like we say the sex of somebody can be a male or a female, the blood group can either be AB. There's no one that can be maybe termed to be superior to the other. And now when these categorical data, which are qualitative, are ordinal, it means that they are they are mutually exclusive and they are ordered. So the difference is that one is unordered, one is ordered when they are ordinal. So the Z stage, it move from one stage to the other until it becomes severe. Now for numerical, it's either is discrete or continuous. Like when we were doing table, we discovered that when you look at the table algorithm from the standpoint of year, some of them was showing blue and the other ones were showing green, and the blue we are termed discrete. So when you are calculating discrete, it means it has a beginning and an end. So integer values, for instance, can be termed as discrete. Typical count, e.g. day, sick, or per year, for instance, those ones that have a particular time does not end, that ends, are known as discrete. But continuous, for continuous numerical variables, you take any value in a range of value, e.g. weight, height, 1.1, they can be continuous, they do not end. So we tend to take them as a continuous value. So we say we have category, we have numeric, and they can either be nominal for category or ordinal, and they can either be discrete or continuous for numeric. And they say there's other type of other special types of nominal variable that are called binary variable or dichotomous variable, which can only take two exhaustive and mutually exclusive value, like 1 and 0. For instance, infected coded as 1 versus not infected coded as 0. So these are binary variable, just like Boolean value. So for data processing, so data processing transforms the raw data into a format that will more easily and effectively process for the user. So it works on the raw data, and once it works, it makes it better, so that when we start the data processing, it becomes easy. If it is not done, sometimes we will have problem when we want to do the main processing. When you look at the platform here, we have different forms of data pre-processing. One of them is data cleaning. As we say, data is always dirty because it has a lot of impurity that comes from the source in which the data is got, the mode in which it's collected, how it's being reported, missing values, not irregular values, the data types not well arranged, amongst others. This makes data to be dirty, so we need to do what? Clean up the data. We have data integration. We have different kind of data. If you look at it, see this one look like a database, this another source, this another source. They are not on the same timeline or the same types, but you need to make them to be uniform, to uniformize them. So data integration is what happens here. So another thing again is data reduction. We have attribute A1, A2 up to A126 for instance, and we have T1 up to T2000. So we need to do what? Reduce it. For instance, T1, T2, 4, 450, T1456 for instance, and A1 to A115. So we have reduced the attribute so that we're able to do what? Work. It is called transformation. That's what we have done. So the question is, why do we pre-process our data? Why don't you work with what you have? So the answer is very simple. We say data in the real world is dirty, very very dirty. Why is it dirty? It has, sometimes they are incomplete, they lack attribute value, sometimes they are inconsistent data containing discrepancy. Some of them comes in code. If you remember our Excel assignment we did, there were some kind of spiral that was on the data that we need to clean. We need to remove some things which are not supposed to be. Sometimes it comes in code that are not standardized. We have age and birthday, all of them coming in different shades, so we need to take care of it. We need to look at even the formatting is a problem. We need to address it. We have data that are noisy, they contain error or outliners. Outliners are those values that completely are extreme to the generalized value available, and when you use them for analysis it makes it to become very very spurious. Let me give you one good example. If we are to juxtapose our income in a given community, and suddenly we just go and bring somebody like Dangote and Otodola and who again, and Tony Olumelu, and come and put them and now divide the average income, discover that everybody is a millionaire and a billionaire, but in actual fact it's only few of them that has the money. So that is where the treatment of outliner becomes very very important, because if you don't do that, you do analysis, it will end up telling you that those people that you want to help actually are the people that needs to help you. Then you have already made a type 1 and type 2 error. So that is why we need to guide against such. So major tasks in data pre-processing. What are the tasks before us? One is data cleaning. How do we do that? Fill in the missing values. So in filling in missing values, there are a lot of things you need to consider. One, do you ignore the records? You only ignore the record if the missing values are less than 5% of the total work. Even at that, in most cases it is not advisable, because it may contain important attributes, important information that may be needed for our analysis. So that will be our last option if we don't have any other, or there's no way we can able to work on our work or improve on our work. The next is to use attribute mean. You use attribute mean. You can use the mean if it is an integer. You can use the mean, which is the average, and fill up those missing values with the mean. You can use attribute mean for all samples belonging to the same class. Predict the missing value by using a learning algorithm, or you can also use other statistical means. So 2, identify outliner and smooth the noisy data. So we identify outliners, and when we do that, it helps us so that we can able to continue work. We can use that through binding. Binding is just like having a basket that brings attributes together, sort the attribute value and partition them into bins. Or you can use clustering when you group values into clusters and then detect and remove outliner. We also have some formulas that are important that can be used to do that. Another thing again you can do is to correct the inconsistent data. Use your domain knowledge. At least you know when you are traveling what is needed, and if such is not there, you can use your domain knowledge to put, oh, this is supposed to be there, why this? Or you are seeing a height of a man and you say he's 12 feet tall. You know there's no how somebody can be 12 feet tall. You are now using your domain knowledge to look at that data again and see what to do about it. And expert decision, people that you have done similar work before and you have gotten a particular pattern of answer, and this one is completely different. You can use your expert decision ability to make such correction. So looking at outliners, for instance, what are outliners? So an outliner is an observation that appears far away and diverges from an overall pattern in a sample. It moves completely away from the overall pattern. For example, we do customer profiling and find out that the average annual income of a customer is 0.8 million. However, two customers are having annual income of 4 and 5.2 million. These two customer annual income is much higher than the rest of the population. So this just like what I say, Dangote or Otedola, for instance, if they are appearing in this environment and you are using their annual income and adding it to other population that has a particular average, discover that they are completely outliner. As you can see, this is where their income are placed. This is where the average of the population is. So if you don't do anything about it, it will make your work to become spurious. It makes nonsense of all your analytical ability. So you need to address it. That is all we are talking about in outliner. So what can cause outliner? One, data entry error. Talk about human error. Human beings are not computer. They can be carried away and they make such error during data collection or recording or entry. Now, measurement error. This is caused when the measurement instrument used turned out to be faulty. So because it's faulty, it tends to give out faulty results. And then experimental error is another. We have intentional outliner. It is commonly found in self-reporting measure that involves sensitive data. Teen will usually typically they report the amount of alcohol that they consume so that they don't see, they want to look pious and sentiment and respectable. Meanwhile, they are not. For giving this example, so they will not report the quantity of alcohol. Or people that report their income for the purpose of taxation, they will always underreport what they get so that they don't pay more tax. So that will cause an outliner too. Now another one is data processing error. Whenever we perform data mining, we extract data from multiple sources. So manipulation or extraction error may lead to outliner in a data set. The next is sampling error. We have to measure the height of athletes. By mistake, we included a few basketballers because basketball player in the sample, and basketball players are very very tall, so it becomes an issue. Then we have natural outliners, like this one of Dangote that I just said. These ones they have their money. It's not that they manipulated it, and if we actually record them with others the way they come, it becomes an error. It becomes a problem. So that is what we are saying. They are naturally occurring outliner. So how to detect and rectify outliner? Any value which is beyond the range. This is the formula now. We know how what to call interquartile range. When you go to your statistical table, you see it there. So if this range minus 1.5 times interquartile range to 1.5 to interquartile range. So when we have this and any value that is either below or above this range, then we know it is an outliner and we treat it as such. We can use capping method. Any value out of a range of 50th or 95th percentile can be considered as outliner. We can also use some coding formulation to do that. Now, data point 3 or more standard deviation away from means are considered outliner. So these important 3 important points can be used. So how to remove outliner? You remove, delete observation, you transform and binding value, you use imputation, or you can treat it separately. So major tasks in data pre-processing. First of all, we have looked at the first one, and now the next thing is data transformation. Data transformation is trying to convert our data from its natural state to the state or to the form we wish to put it, so that we can be able to use it for analysis sake. So we can also do some things. One of them is normalization of data. The word normalization comes from normal. So how do? We scale attribute to fall within a specified range, so that we don't have attributes that have different shades of ranges. It makes it a scattered kind of arrangement, which is not proper. So we scale by using mean and standard method. Now, to have attribute construction, replacing or adding new attribute inferred by existing attribute. We can change the attribute or can add new one in order to get our desired result. The next one is data reduction. Data reduction. So when we are talking about data reduction, we mean that the attributes in the value we want to use for machine learning may all not be useful to us. It's not everything on the column that is needed. Remember, there is ID, there is customer ID, there is stock ID, there is a different kind of ID. Those IDs are not needed. Sometimes even the date may not be needed for analysis, because what are we analyzing date for? So some of these things are removed so that we can actually have the main attribute that we need for our work. So you say removing irrelevant attribute, that is called attribute selection. So principal component analysis, which is PCA, numeric attribute only. So searching for lower dimensional space that can be best represent the idea. So any data that has high dimensionality will be removed in order to allow us to do our analysis. So reducing the number of attribute value. The value binding, you use histogram so that we can be able to be having averages. It tends to smoothen our plot to make it easy for analysis. We have clustering, grouping values in cluster, or have aggregation or generalization, where we tend to have just one single line of code as regards to what we are doing. So another thing again we do in terms of data reduction is reducing the population by sampling. So if a sample can have the attribute of the population, so why using the whole population? So we pick the sampling and apply it and get our result. So you obtain smaller sample S to represent the whole data set N. So major tasks in data pre-processing is data discretization. So consider data reduction mechanism, because it diminishes data from a large domain of numerical value to subset of categorical value. So all we do is to reduce in order to help us. The smaller the better when it comes to machine learning algorithm analysis. So now for our data set is normally broken into 2 or 3 depending on what we want to achieve. The first is training set. The data set, assuming we have a data that is 1000 rows, for instance, we can decide to break it and use the larger proportion of this data set as our training set. So a set of example used for learning where the target value is known. So we know what we want to achieve there, so we continue to work with it until we get result. So that result now is what we use with the system, and after we have gotten the result, we can also now go ahead to do either of the test validation set or test set, or two of them at the same time. So a validation set is a set as an example used to tune the architecture of the classifier and estimator. So for data validation, we just kind of make to tune it to get a better result. But the test set is used only to assess the performance of our classifier. It is never used during the training process, so that the error on the test set provide an unbiased estimate of the generalized error. So the reason why we break our data is to allow us to use our training set to practice the algorithm practices on our test set, and after that it doesn't have access to the test training set, doesn't have access to our test set. It is only when we have finished that we now subject our algorithm to the test set, so that if peradventure we see an error, we know that that error is truly an error and not any other thing else. So we can be able to make generalization based on that error. So as you can see, this is our full set data set, which we broke down into training data set by this proportion, validation set by this proportion, and test set by this proportion. Now this test set, we keep it aside, we are not using it. Now we now subject our training set to our model. After we have subjected it, we also go to our validation set and still use it to fine-tune our model in order to get a given set of results. So based on that, our model can be able to make what? Prediction. Now for us to know the accuracy of our model, it is when we now subject our model now to this test set that was not exposed to the model initially, that we can know whether our test set is accurate. If the accuracy is high, we can now say that the model, the algorithm has been able to be trained to make good prediction. So this is what we are talking about. So for exploratory data analysis, which I have touched earlier, just like a recap, you say it is an approach to analyzing data sets to summarize their main characteristics, often with visual. A statistical method can be used or not, but primary EDA is for seeing what data can tell us beyond the formal modeling or hypothesis testing tasks. So EDA is always good to help us see our data better. So have categorical data and numerical data, just as we have discussed earlier. So we'll be stopping here today. In our next class, we'll continue with respect to our machine learning introduction and the expectation that have to do with our learning algorithm. So we'll be stopping here. See you in the next class. Bye bye.